really focused on are employees that directly interact with our customers. So we have 35 product support engineers and 50 customer support engineers. Essentially, these are like customer support engineers, like your level 1 customer service, and then if it's higher importance or escalated, it will go to our product support engineers. If anyone has a problem with their helicopter, then they will directly contact these employees. So it's really our front line of customer service, and they're a very important asset to us. They'll provide 24/7 support, and they'll handle around 1,100 service orders per month. So, in addition to interacting directly with our customers, it's important that they record every single interaction, communication, problem, and solution that they come across, because we have a very long product lifecycle, and we can collect data for years on this, and it's going to remain important for 20 plus years on our products. And that's really where this came in. Our support engineers utilize all of this archive data from our past product issues and experiences, and this leads us to kind of our pre-project state. Our data that we were archiving initially was in a legacy system accessed through an application called PSE Toolkit. This was designed specifically for their use, but it's aging, and since then we moved on to SAP CRM. So all our data that they were archiving, all those interactions, we put that now into CRM. So there was an effort before this to migrate that legacy data over. It worked in most parts, but we still ended up with missing and incorrect data. So what you kind of ended up with was these support engineers, they're using this legacy application to access certain sets of data sets, and they're using SAP CRM to access the new data sets. One of the main problems was, well, our legacy application is aging, and SAP CRM wasn't designed for them to search on this. That leads to kind of our three main issues. So, core system performance. SAP CRM, again, not designed for these support engineers to search on. So, it could take hours for a search, and it's not intuitive to find what they're looking for. The lack of usability, again, it wasn't designed for them. It was taking our support engineers way too long to find an answer to a customer's question. Finally, the initial big effort before we really delved into this solution was the missing and incorrect data sets. So we needed one source of truth, one source of data before we really gave our business a solution. And there was a big effort to correct all that data in SAP CRM. And then once we did that, we could really step into delivering our solution, which Magesh will go over in detail.
Thanks, Jason. Okay, the solution was based on solar. So you heard about Splunk before, and there were a whole lot of other research technologies like Elasticsearch and so on. We have a big data environment, which is we have Hortonworks installed at Hortonworks at Bell. So the reason we picked Hortonworks is because we are in partnership with SAP and Microsoft, and this was a couple of years back when SAP had a good relationship with Hortonworks and Microsoft in their Azure cloud. They deployed HP Insight. So it was kind of a good ecosystem for us. So going along with the same thought process, we said, who is Hortonworks, which technology is Hortonworks picking, and they are going with solar. So we ended up picking solar for the reason that it fits the ecosystem, right? So like Chase mentioned, we have data sets sitting across different areas, and this data consists of emails, documents, PDFs, spreadsheets, you name it, everything are there, zip files and so on. And we also have structured data sitting in a database, right, CRM database, and Oracle database and so on. As part of the migration effort, we had most of the data, pretty much everything, came into SAP CRM, but CRM is really slow. The usability is pretty bad, the search capabilities are not there. So when we designed our solution, we did not want to implement this project actually. So we tried our best to kill this project first. So what is it that will make this project irrelevant, right? So if SAP comes up with a mechanism where the searchability and user interface is good, and it returns searches in a split second or in a few seconds rather than several minutes, and if it has the right data, then we're all golden, right? We don't need this project. We don't need to go through this jump through the hoops. But that was not going to happen. So we started this project about a year back, and at that point in time, SAP CRM was going to implement a search technology, or they already have a search technology called Plex, and they were going, but it was not fully functional. They were going to improve it. They were going to come up with the next version of CRM, and it was all going to be good. But as late as about 4 or 5 weeks back, I heard that SAP has abandoned that path, which means they're not going to implement any search solutions or Solar-like search in CRM. That's what I was saying. So this solution was a complementary tool to data sitting in SAP CRM. So what we did was we extracted the data from CRM. Right? So this data is both data sitting, structured data, and a little bit of unstructured data like notes and so on that you see on screens. That kind of data sitting in the database. And also the emails and PDFs and PowerPoints and all kinds of stuff they exchange that is sent into the system. The customers will send us documentation. We will prepare custom documentation, send it to customers. So all of that interaction records is part of the data set. And we got all of the data extracted from CRM into what we call the how to cluster Solar Cloud. We'll go into a little bit of detail in the next slide. So we extracted the data, and the extraction, data extraction from CRM, for those of you who know SAP, it's not like any other system where you connect like the ODBC connection and get it out. So there are things you need to have in place. The structured data comes out as an XML document. So actually there's an IDOC. So when somebody makes a change to a CRM a service order, it creates what is called an IDOC. And this IDOC is converted by SAP PI into an XML document. And we get that XML document. And for each one of the service orders, the associated documents like Word and Word documents, all the associated documents, emails, and so on, that is also stored in the CRM system. And we had to write some custom code to extract that and send it out to a file system on the CRM server itself. And then we had to use a third-party tool. We couldn't use anything else, but Axway was installed, implemented as well. So we used Axway to take that data from the file system in CRM and put it in Hadoop cluster. Once we got the data sets for each service order, we get the structured and a little bit of unstructured data in XML document, and then we get all the associated unstructured data also in documents. We kind of combine all of those things together in use a Java program and Java API to extract all the data, put it in what is called a Solar XML, and ingest it into Solar. And once all the data is in Solar, then we have a .NET user interface connecting to Solar that provides the user interface for the customer service team. When we started this project, it was more, we didn't have a very clear definition of what exactly we wanted. And it was more as a search tool. That is how conceptually started late last year. But then as we progressed to the development phases, then it became really clear that what we need is a real full-fledged application for the front end, for the customer service tools. So it didn't immediately happen, and oh, they need an application builder. As we went through the process, then it happened that, okay, they need a full-fledged application, and so as a backend, we need a really deep, fully functional user interface. We'll go to the next slide. I don't have a presentation, a demo per se, because we have customer data, we cannot demo the system live. And it's pretty painful to create the artificial data and ingest it and so on. So we just have a couple of slides. So this is the real more in-depth architecture, if you will. So data is sitting in CRM, and when a change is made to a service order, it generates an IDOC, and IDOC's sent to another system called PI, and this is also an SAP system. It's an integration tool. So PI takes the IDOC and converts it into an XML document. This XML document is stored on the Hadoop. We're not using Hadoop file system here. It is basically the Linux file system in the Hadoop, where Hadoop is installed in a Hadoop cluster. And the reason we're not using HDFS and storing the files on Hadoop is because these are small files. So it will be much smaller than the block size, and so it will be wasting space. So we are just storing the raw files, both the XMLs and the attachments and so on the file system. So you see the emails and attachments going through a different path, and the XMLs going through a different path. They all end up in the utility node in the Hadoop cluster. And the first thing we do is, then what happens is, on the utility node, we wrote a Java program to do multiple things. One of them is to take all of this data and group them in individual folders for each service order. So from the naming convention of the files, we know what service order it is, and then we create the folders, put it all in, and sort them into different service orders. Once we do that, then we parse the XML files, extract the fields we need, and then we also get the attachments, and we get the content of that. We used Apache TCOM for that. So we use the TCOM parsers to extract the content out of all the attachments. And once we have all of the data, we put all of those things together in what is called Solar XML. And Solar just needs in a specific format, so it's nothing fancy, it's really simple. So it's tags and data within the tags, that's all it is. And we had to create the field names that we actually will be searchable, we can search. So we also had to define the Solar schema. So Solar, I don't know how many of you are familiar with Solar, but it's Solar Elasticsearch, all of these things. Whatever data you consume or ingest into Solar, you have to still define what format or what structure it is going to be in. And that is called the schema. It's, the terminology is the same, but it doesn't have a database, so you need to define what structure it is. It's an XML file, so there's a file called schema.xml. You define the schema, and you tell Solar this is what it is. So a Java program took all of this data, and for each service order, it built Solar XML and ingested it into Solar. We had to do a one-time data extract from CRM and ingest all of the data into Solar. And we had about 200,000 service orders, a little over 200,000. It took us, extracting from CRM, again, was a little bit painful. It took us over 3 weeks to get all of these data sets extracted out. Because of logistics, we didn't want to impact production, what was happening there, and so on, so we had to time it. So once we got all of the data sets extracted, we did the one-time ingestion into Solar, which was pretty fast. This in 2 days, we just ran 3 parallel processors to ingest all of the data into Solar. But we could have done it faster, we could have done a lot more engines in parallel, not just 3. So we could have pretty much accomplished loading all of the data into Solar in about 8-10 hours, but we did it early. After the initial ingestion, then what happens is you need to get data updates. Right now, we are getting the data updates from CRM every day. So all the changes that are made to CRM, the IDOCs are generated in real time, and it goes to PI, SAP PI, and it creates the XMLs in real time and sends it to the Hadoop cluster. All that happens. But the attachments part of it is a daily process. It runs one every day, and it extracts all the attachments for just the new and the change service orders and extracts it out. So we get that once a day. We want to speed it up because there's no reason why any of these systems cannot function more frequently than 24 hours. But it's a matter of getting a couple of things ironed out. So we will, in the next few months, increase the frequency and make it like an hour or 30 minutes or something. We won't be exactly real time, but we'll, because of all the logistics and more extracting attachments and so on. But we'll try to get it as close as possible to real time. Once we get that, then in Solar, what we have is a 3-node cloud. So what this provides is Solar out of the box. It provides the cloud infrastructure, and it provides redundancy and availability. Right. So the way we have to set it up is on the 3 nodes, the data is stored in partitions, right? So I can say how many partitions and how many replicas I need for each data set. I have 3 partitions and each one has 3 replicas, so it's distributed across all of the nodes. And if one node fails, I still have the other 2 nodes with the data, and my user interface will still be supported. And any query you submit to any of the nodes, it sends it out, distributes it, and it collects the aggregates information and reports, sends the results back. So it doesn't matter which node you're sending it to. Say the data ingestion or query. Either way, you can send it to any of the nodes. So it's pretty cool. It's really stable. They haven't had any problems so far in the last 6 months. So we've been live. So we have really, really awesome user experience and user feedback on that. So that is about the architecture. Now, the user interface. One of the big things with this project was the user interface. Like I said, when we went into this project, it was more of a search tool and keep the user interface really simple. All the customers need is a quick way to search information. But what it turned out to be was the user interface was a very, very critical component of the search of this application. And in general, thinking about any search application, right, whether it's Splunk or whatever, you really need to, it's one thing to say, I want the ability to search. But when you're providing an application or when you're providing this functionality to the end user, what really makes the difference is, fine, I can do the search, but how is the user information presented? Right? You need to be able to present it in a very clear, concise fashion that is useful. So what you see here is, this is the very initial screen. So you go log into the application and you don't type in anything in any of the fields, right? You just hit search. It brings back search star, right, for that matter. And whatever the default was index mechanism is, it just brings the data and it presents the top 50 or 100 rows that brings whatever order it has. It has the facets in here, and we also have what is called the advanced search. And the entire results that it brings here is like in split seconds. So it provides the initial high-level information, like service order number, model, and so on. And if you see these boxes, once you click on those, it gives you a little bit more information. And you can, just like you do on Amazon, you can do faceting. You can do better filters. And this one is search field with suggesters. So when you can do a couple of things. There's a free text search box. You can type in anything, and it provides the ability to type in the search in Solar syntax. So you can do plus and minus, and whatever the Solar syntax provides, you can just pass it in. So you can do really, really deep searches in this, really focused search. But if you don't want, most of the users typically type in a couple of words, 2, 3 words, and say blade and crack and repairs or model numbers and so on. So based on whatever user feedback you got, we designed the user interface to make it really convenient for them, based on whatever user experience they have. So these are some of the categories that they typically use. So we built suggesters, and this was not available out of the box. We had to get through a couple of hoops and create separate suggesters. But what this does is, as you start typing in, it will start filling in the information for you. It will give you the list of all the models and activity types of what is available, so they don't have to remember everything. And then we have the facet. I already talked about it. Just like Amazon, everybody's familiar with it. Faceting is provided there. And when you click on any of these service orders, you get a pop-up. And this pop-up has more information, a summary, notes, and all that. And emails and attachment, that is another key thing. If you search for a term and it's available in any of the attachments or emails, it'll show that it'll color code it. So that you don't actually have to open the emails and attachments to actually see if the term is in the email, it'll automatically color code it and highlight it for you. So we built a lot of sophisticated user interface features on top of the search engine. So the search engine provides the speed and the capability, and the user interface provides usability. The combination of these things was really valuable.
Josh, quick question. So,
Yeah.
are you able to drill down into the individual line item?
Yes. Yeah. Every.
Take it back to CRM?
No, it doesn't really take you back to CRM, but this is one-way feed, and this is not data entry either. It's just search capability. So the way they use it is they use CRM for all the data entry purposes, but this is just for searching and answering phones. One of the biggest problem was when the customer called, they would say, okay, give me your problem, I'll take it down, and then I'll research it and call you back. Now with this system, they can answer on the phone right now and say, yeah, you don't know where to hang up, I'll hold on just a second, I'll let you know.
Magesh, you mentioned Elasticsearch. So, are you using Elasticsearch itself or another distribution?
So we're not using Elasticsearch, we're using Solar. So Solar is, I believe Solar and Elasticsearch started with the same base, and then we found the.
Do you know why you went away from Elasticsearch?
Oh, yeah, maybe you're not here. I explained because we are SAP shop, and we also heavily use Microsoft. And because of those two reasons, we picked Hortonworks. And Hortonworks is a partner with Solar. So because of the ecosystem, we picked Solar.
On your user interface, when you put that together, did it come out of your team doing the user interface, or did you actually work real close with the customer service representative in order to get it right?
You know, you brought a very good point. We worked very closely with customer service representative group, and one of the reasons for our success of this project was amazingly successful at Bell. They are going to recommend it for like a company level award, and the parent company is Textron, so multiple companies like Cessna and so on. So this project is going to nominate it for like a President's Award someday. So the reason for the success of this project, one of the main reasons was we had really, really good people in the business side supporting, telling us exactly what they need. Otherwise, we would not have been, if it were me, I'm not good at using the page, I would have just done something like Splunk and said, hey, here you go, you can search, end of it, right? Bigger. So yeah, they really helped us identifying what it is. It was a lot of back and forth. For instance, we were getting some emails from CRM in a text format because the date was short, and we were displaying it as a, then they came back and said, okay, convert it to like MSG format. I said, okay, how do you do that? So we have got another third-party software and made it happen. So there are a lot of these back and forth happening. It took us like a good 9 months to implement this project. It would have been done a lot faster, but
Now, most of the successful projects that I've worked on, you have always had business closely aligned with
Yes.
the technology group,
Yeah.
and they are the ones that define the user interface because they're going to use it. So,
absolutely, that was true here too.
So you have all this data on these customer service tickets. Is the company using them to predict when customers are going to need service and what problems are coming up in the future?
Yes, so that is the next phase of the project. So right now we have all the data in Solar. So we are exploring using Banana and Kibana and Logstash and so on to analyze the data and see what kind of problems are, based on keywords and terms and searches, what's going to happen. Another thing we have not done yet is we are not logging the searches. So what is actually the user actually doing? So we are working on getting the Solar logs also analyzed using Logstash and feed it back into Solar so that we can do some analytics on that.
So just following up on that, if you're going to use Banana or Kibana, do you expect having to re-extract this data and put it into Elastic?
No, actually Kibana sits on top of Solar. So it is.
So you don't have to use Elasticsearch and just
Exactly, it sits on top. So I don't have to rehost the data, redo anything with the data. So it's,
how often do you ingest the data from SAP?
say it again?
How often do you ingest the data from SAP?
Okay, so the one-time deal was whenever something major happens, right? If there's a new field or something they're going to add to all service orders, then I'll have to reingest the whole thing. But we ingested the data twice so far. Once when we went to live, and then we found a major issue we had to reingest, so we did the whole thing over again for a weekend. But we ingest the delta, which is the new service orders, and we change to existing ones once a day. But we want to increase the frequency. It's just we have to get it under the logistics, nothing, no information.
So is it during the batch window or?
Right now we have 5:30 in the evening. We just pick the windows, and after the customer service folks pretty much log off and so on. So no way to please handle this.
Just a curiosity, you started off saying that the runtime issues of the CRM,
Yeah.
SAP CRM versus this. So what kind of difference were you seeing now after this implementation?
Oh, so that is the thing here. So what used to take them 4 hours is now taking them 2 minutes. So that is the kind of performance improvement you've seen. And this is, I need to put a picture of the customer. They're actually doing this. They're jumping up and down. So,
Yeah, when you're doing all of your data from the CRM system, do you need to worry about incomplete sets of data? So, for example, you might be in the middle of putting stuff into.
Oh, right. So the question was incomplete data sets in CRM. No, I really don't have to because SAP CRM takes care of that. That was one of the issues we had a little bit earlier on. But it doesn't let you finish the service order if you don't fill in all the fields. And the fields we depend on are based on us.
So the instruction piece of the data, does not metadata, right? You have to extract the metadata of the.
Say it again?
The unstructured data.
Yes.
There's a metadata that you have.
So the actual data itself. So Apache Pika is an amazing piece of software. If you don't know familiar with it, go check it out. And it gives you all the data. So if I give it a Outlook file, it will give me, and then I say, give me the from address, to address, and so on. It will give me all of those. And I can see the metadata and the data.
Do you use like a default schema for that, or you that Java is generated default schema or dynamically marked?
So what I did was we use Apache Pika processor to extract all the fields, and I cherry picked what I wanted and pushed it into Solaris.
So this is a quick one, 2 elevator pitches. One to an executive, one to a CIO, right? Business executive, CIO. So why is this great? What did it do that was awesome? What are the 3 things at the business level and 3 things at the technology level?
Okay, excellent question. So that's what this is. So this is lightning speed instant search.
To do what?
To look at your service orders and find out similar service orders that have had a problem before. So somebody's calling you to say, hey, I have a problem with my plate for this model. All you do is Google it or basically search here and say, these are all the issues I've had and this is the solution.
It's similar, right?
Yeah, similar to that. So we have a value scatter surface. We did doing the bag of word search. We haven't done a whole lot of semantic search and all that kind of stuff. That is doable, but it's probably we went with the 80-20 rule. So 80% is simple, bag of word search is good. So that's what we're doing.
Excellent. Excuse me with this.
All
Let's
right.
take some questions off on the floor. I want to thank you very much for your time.
Thank you,
It's
sir.
very impressive that. Well, ladies and gentlemen, that's very interesting. You know, you can go into SAP CRM in that form. Next speaker is Bill Haney from Basho. Very interesting company. He's based here in DFW Market. He's also the event sponsor. I'll pass it on to him.
Let's go ahead and give this to Sasha and let him get wired up. So the good news is we did bring lunch. So if you can give us 5 minutes, let Sasha get set up. During that time frame, if everyone just go in the back and help yourself with some pizza, I hope that we have a flavor that everyone will like. And we'll kick this off in, say, 5 minutes. Thank you very much.